Today we are going to solve problem number 2684 from the Leetcode. This is problem number 2684, maximum number of moves in a grid. I'll just try to explain you the problem first of all in my own words. I hope that should be simple than what is explained here. Post that, we'll try to intuitively build on the solution. We'll write the code about it, or if the code can be further optimized, we'll optimize the code and rewrite the code. First of all, we have provided a grid. Let me just write the grid for you. Now if you look at it, this grid is nothing but a two-dimensional matrix. The problem is pretty simple, okay? You can start from the first column and you can move in the rightwards direction. This is important. Just one condition, whenever you are moving, you have to move to one greater number. Let's say if I start from 2 over here, the possibilities that I can go to is 1 towards 4, another possibility is here, isn't it? These are the only two things which I can move to right. If I have to start from 5, if you look at it, from 5 I cannot go to 4, from 5 I cannot go to this 4, from 5 I cannot go to this 4 as well. If I have to go from 3, let's say, from 3 I can move to this 4, this is one valid move. Again, some part of it is moving to right hand side. I can move to this thing, this is also going to right side, and also the number is bigger. I can move to 9 as well. This is again partly to the right side and the number is bigger. Let's see, from 10, can I move to any place? From 10 to 9, no, I cannot move. From 10 to 4, I cannot move because both these numbers are smaller than the previous number. First of all, let's try to track how can we propagate from 2. From 2 I move to 4 or this 4. From 4 I cannot go to 3 because 3 is less than 4. But from 4 I can definitely go to 9. Let's go to 9 in that case. And always remember, you can only move one step at a time. Now from this 9, where can you go? Can you go to 5? No, because 5 is less than 9. Can you go to 3? No, because again 3 is less than 9. Can you go to 11? Yes, definitely we can. 9, can you go to 11? Yes sir, we can. Okay, now you see how many nodes did we traverse in this process of propagating from 2 to 11. First was 4, second was 9, third was 11. That means what I have got here is 3. 1, 2, 3. 3 nodes have traversed, right? From 2, there was another option, remember? From 2, I could have gone to this 4 as well. This was there. From this 4, I could have gone to 2, 3 or 9, but 2 and 3 are not valid, so I can only move to 9 here. Now, if I move to 9, from 9 again, only possibility would be to go to 11. In this case, the number of moves that I have taken, the number of nodes that I have moved is 1, that is 4, 2, that is 9, and then 11, that is third one. Again, the output would be 3. Let's try to move from 5. If you move from 5, actually you see you cannot move any place. So this will result in 0 here. Let me just write it here. This is 0. If I start from 3 now, let's see what happens. If I start from 3, I can move to 3 possibilities. One of the possibility is 4, another possibility is this 4, another possibility is this 9 over here. If I go to this 3 to 4, this is one step. From 4, again I'll go to 9, then 9 to 11. This will again give me 3, right? So one of the options that this 3 is going to get me is 3, right? Let me just write it down here somewhere. This will be 3. Let's see what happens if I move this path. 3 to 4, this 4 to 9, one possibility. This 4 to 13, another possibility. 4 to 2, we definitely cannot go because 2 is less than 4. From 9, again I'll move to 11. So how many nodes are there in this path? If you track this path, 3, 4, 9, 11. This is first, this is second, this is third. Again, it will give you 3. Let's see this one. You go to 4 to 13. From 13, you go to 15. There's only one possibility. How many nodes did you move here? 1, 2, 3. You move 3 nodes over here. Again, let's see from 10, where can we go? Actually, we cannot go to any place. Now you see, we have traversed to all the locations from all the initial points there. And the maximum number of nodes that we can traverse happens to be 3. Now this 3 is the answer that we need to find. So basically, this 3. 3 is the answer that I need to find. That means what this gives me is 3. 3 is the answer over here. Now the problem is, how do we solve this? Okay, this is pretty simple again. Exactly the way that we did it here, we have to do the same thing in the code. Let's try to build intuition over it. First thing we know, we need to traverse over this grid. Now the problem is, how do we traverse? If you look at the problem carefully, you'll get the solution. Let's say you are starting from 3. Okay, from 3 you had to move to certain direction and then calculate the maximum number of moves possible. Okay, now let's say I just do one step. From 3, I move to 4. The moment I move from 3 to 4, can I say that my problem is just reduced now. The same thing that I did from the row 1, the same thing I have to do from row 2 as well. If you think about it, once you have moved to 4, you can just forget what was there in the previous row. Now you have to move from 4 to some place. Again, the problem becomes the same, right? That means you add 1 to the solution because one step you have already moved. You have to again solve the same problem. You can go to 9 or 13, then from 9 you can move to 11, from 13 you can move to 15, whatever it is. But at this point in time, when you are at 4, what you know essentially is you have 1 in your pocket already, and now you want to solve it for the remaining of the system. Now let's say you move from 4 to 9 already. The moment you move from 4 to 9, what you'll realize is now you do not need this previous row altogether. From 9, you have to move to certain position, and when you are at position 9, you have already moved 2 positions, right? That means 2 plus whatever comes from the remainder part of it is the result, isn't it? So in this fashion, we can actually solve this entire problem. So what I'm actually telling you is this is a recursive problem. Same problem is happening again and again and again. The problem is pretty simple. You do not have to think about all the rows and columns. You just have to think about one row at any point in time. What you need to do is go to every point, traverse, keep a track of maximum number, traverse all the possibilities that are there, and then end of the day, return maximum of that number. You'll have multiple maximum values. One max you'll calculate from 2, another max you'll calculate going from 4, another max you'll calculate from 3, and then 10. End of the day, you have all the values just the way we have 3, 3, 3, 3 we had. We created max of 3 that happened to be 3 in our case, but whatever it is, end of the day, you have to return max of all the values. Looks simple? It is actually simpler than what it looks like. Now let's try to write the code for this. The code is pretty simple. First of all, we'll write a core function that is used to traverse. Okay, just the way we discussed how we do it recursively, we'll do in the similar fashion over here as well. Okay, so let's write code for this. Now first of all, let's try to see what this function is actually going to do. This is going to recursively traverse over the grid just the way we discussed. So essentially it will take 2 parameters, row and column. Now what I'll do is on this row and column, I'll do some manipulation to create my next grid element. That is, either it can be diagonally upwards, diagonally downwards, or exactly right hand side. Okay, and this function's motive here is from this row and column, what is the maximum value that is possible. Okay, so let's assume that to start with, maximum value is equal to 0. With the passage of the function, we'll find the value of this maximum value again. We'll calculate something. Okay, end of the day, this function will return the maximum value from it. Now let's say the possible directions that I can move to are 3. One of the value is diagonally upwards. What that means is -1, 1. Another value that is possible is exactly right hand side, that is 0, 1. Another value that is possible is diagonally downwards, that is 1, 1. What this is supposed to mean is if I add any of these values in this list to my row and column, I'll get the next element. Let's see how. What I'll do is for dr, dc representing row and column in directions, we need to create a new direction. This will be equal to row plus dr, col plus dc. This will be my new direction. Now what I need to see is I've created the new direction, but I have to see if this new direction is valid also or not. Here I do not want to overcomplicate things. I just write a hypothetical function if valid point, that is this new point that is created, new direction, if this is valid or not. Now just thinking out loud, how can I check if the new direction is valid or not? First thing, it has to be in the range of the grid. Okay, let's say m and n represent the dimensions of the grid, and one more thing that I need to check is whether the next value is actually bigger than the previous value or not. To do that, let me send grid also to this. Now this function will return me a boolean value, true or false. If it is true, then what do I do? If it is false, what do I do? If it is false, I don't do anything because then there is no point of solving it. Okay? If it is true, what do I do is I change my maximum value. Now what will be the new maximum value? Initially it was 0. Okay, if it is true, my new max value will be either of two things, either the current value or the new value that is calculated, but we want to take the maximum, remember. So what we'll do is maximum of max value, or another possibility is I'll move to the next row and then calculate the value from there. But while moving to the next row, I have to make sure I add 1 to it to compensate for the current row as well, right? So what do is I do a traverse and I pass new directions to it. this function takes row and column. So what I'll do is I'll pass new direction of 0, that will be row, and new direction of 1, that will be the column. Now you see this, at any point in time, what I'm doing is I'm recalculating maximum value and resetting it to either of two things. One, the current value. Other possibility is go to the next row and find the maximum value from there. I'll do this iteratively and I'll find a maximum value at the day, which will be set in this variable over here every time. Once I'm done with everything, once I'm done with all the rows, because it is calling it recursively, end of the day, what do I need to do is I just need to return max value from it. And this will be the answer to my one of the subproblem. Okay, this one here, this entire code which I have written over here that you see, this just solves the problem of one index, because this takes one row and column, right? So we have to call this same function over all the values in this blue circle over here, isn't it? And once I do this, the same thing for all the values in this blue box, and I calculate the maximum value, because every of this thing 2, 5, 3, 10 will give me something, right? And I have to find maximum of all those values and return that. So what we need to do here is, let's write some more part of it. Let's say for a row in range, how many rows do we have? M rows. Okay, for row in range M, we have one more max value here. In the outer scope I'll define. Now let's write the outer part of the function, where we'll just call this function which we have already created. Remember, the core part of the logic we have already created. We are just doing some workarounds to make sure that this code works for all the values. This will handle any one path. I just have to make sure I provide all the paths to it one after another. It will give me a overall maximum value. This maximum value, remember here, this one is supposed to calculate maximum value for just one path. I can have multiple of such paths. One path originating from 2, another from 5, then from 3, then from 10. I'll pass all these values to this function, keep a track of max value, and then return the max value. Let's see, I create another variable that I'm calling as maximum value. Maximum value. Let's say I initiate with this with 0. Iteratively for I in range of M, basically I want to move over all the rows. Okay, now what do is maximum value is equal to, again the same thing that we did last time, max of maximum value or traverse. Here I'm not doing any addition of 1, because here it's the first row itself. Traverse in range what? I know my column will always be 0. I just need to iterate over the row values. Row value is given by I and the column will always be 0. Okay, end of the day I'll create some maximum value for all these rows now. Okay, and then I will just return maximum value. Now this shall solve our problem. Let's try to see this. I'll just write this piece of code in my terminal. Okay, the same piece of code. Now this here is the function that we had just written. I've just fine-grained some values here and there, but end of the day it's the same function. I've created one M and N that represents my rows and columns, and I have created one function that I've called it DFS now here, and this is just traversing over the same thing. I have dr, dc, I have new row, new column, and then I'm checking here if it is a valid function or not. Okay, the same thing which I had written there in one line, if it is valid or not. This one line I'm checking if it is valid or not. What I'm doing is I'm checking if the new row is greater than 0 or not, less than M or not. Similarly, new column should be greater than 0 and less than N. And also this should be the next value, and also the next value in the iteration should be greater than the previous value. This I'm checking here. Once I do this, what I do is max move is equal to max of existing max move, and then 1 plus DFS of the next value. Okay, and then I return the max move. Here I have max moves possible, and I iterate over all the values and then return max move. Let's try to run this function. What happens? Let's see what is the output here. Should be good. It works for us. Now let's try to submit this. We have time limit exceeded. That means we need to look at the complexity of our problem. Okay, let's see what is happening here. I'll start from this 2 over here. I go to 2, 4, 9, 11 in one iteration. Then I start from 2. I go to 2, 4, 9, 11. See this? From 5, I won't go to any place. From 3, what will happen? I'll start from 3, 3, 4, 9, 11. I'll start from 3 and I'll go 3, 4, 13, 15. I'll go to 3, 9, 13, 15. Now, if you look here, okay, there is a problem. In the worst case, what we might do is we might actually traverse over the same path again and again and again. As you see here, this 9 to 11, I traversed over this path while I came from 2 via this path, this 4. Again, I came via this path. Again, from 3 when I was coming, I came via this 4. Again, while 3 I was coming, I came via this path. You see, already this is covered 4 times over here. Now, in the worst case, let's try to see how much we'll cover. Let's say that is the worst case. So what we will end up doing is, here, to understand the complexity, we have from every place 3 directions to grow, okay? And how many places are there? M cross n, okay? M cross n positions are there, and from every place, every of this M cross n, that is M is in this direction, this is n, and this is n here, this going downwards direction, okay? Now M cross n, from this every M cross n, I have 3 possibilities to go. Make sense? That means first box, I have 3 possibilities. Let's say first one, I have 3 possibilities, okay? The second one, again I have 3 possibilities, that is cross 3. Third one, again I have 3 possibilities, cross 3. Fourth one, again I have 3 possibilities. So on, if I keep on doing, it will be M cross n. Can I say this? That means my complexity would be 3 to the power M cross n. Now this is definitely huge. First of all, it is an exponential complexity. Second of all, the exponent is way big. It is M cross n. In this case, you can imagine M cross n value would be the length of this array here, all these numbers. Now we need to fix this. If you look at it, we actually do not need to cover 9 and 11 4 times because we have traveled once from 9. If you look at it, from 9, this becomes the subtriangle, okay? From 9, it does not matter from where you are coming. The answer will always be 1 because when you travel from 9, you can only move to 11, isn't it? So when you're coming from this 4 or this 4 or this 4, the answer will always be 1. So do you actually need to traverse from 9 again? In the same way, say you are at this 4 over here, the answer will always be the same. That is 2, 4 to 9 to 11. Now it does not matter from where you're coming. You might be coming from this 2 or this 2. So what we need to do is, for every value, once we calculate a result, we need to store that result somewhere. Once we have stored that result, the moment we see this value was encountered previously, we'll use the stored result so that we do not need to do the same computation again. This will save us time, and these test cases which are failing for us, not exactly failing, exceeding time limit, these will also pass. If we do this, then what will become the complexity? If you see, then how many boxes will traverse? That is the problem, right? If I want to see what is the complexity, the problem is how many boxes will I travel. Now I know I'm not going to traverse to a box more than once because I'll store them in some memory location. And how many boxes are there in total? I would have M cross n boxes as the last time. And this becomes my time complexity then. I hope this is clear. Now let's try to see how do we optimize our code to fit this scenario. As we said, we need to store all the values in some memory location. That means we need one memory location. What I'll do is I'll create another variable. I'll call this memo. This will be an empty dictionary for me. Okay. Now what I need to do is, before I send this value here, returning maximum value, what do I do is memo of row and column, which is a tuple here now, is equal to max value. What I'm doing is, before returning the max value, I'm storing it here in my memory. And also one more thing what I need to do is, if something is already there, before I run this recursive loop over here, just the moment I come inside the function, if row, column in memo, that means if I have already stored it, in that case, do return memo of row, column. Now you see what I have done is, the moment I come to this traverse function, the first thing I check is, have I already calculated this thing for this row and column? If yes, then just return it, but you have already stored it. If not, do the normal logic that you normally do. End of the day, before returning it, store it in the memo variable again and then return the value. Rest of the logic entirely remains the same. Same changes, I've made to the code as well already here. Now this is exactly the same thing which I've done here. If you see, I've just introduced one memo variable over here, and then what I'm doing is, if row and column is in the memo already, return the value of the corresponding row and column, and before returning here, I'm storing value in the memory variable. Rest, all the code remains the same. Now let's try to run the code first of all. What happens? This is working fine. Now let's try to submit as well. Hopefully this code should run all the test cases without exceeding the time limit. And yes, we have solved it. If you look at it, we have already solved it. So this sums up the solution. If you have any confusions regarding this, if you think there is something that I can change in this, please let me know in the comment section. Please like the video if you like the explanation, and subscribe to the channel if you want more of these.